we made it to our third video. Chapter 1, Lesson 3, Properties of Numbers. Your objective in this lesson is to recognize the properties of equality and identity properties. Recognize the commutative and associative properties. The standards that we're going to be addressing is Algebra Standard SSE 1B and Algebra Standard SSE 2. In this objectives, what that really means is what we're really going to be doing is your job is to be able to solve the problems based on how you did your order of operations, but now you're actually going to tell me what property happens every single time you do something new to the problem. And then you're going to learn about the commutative and associative properties. These probably sound familiar to you because you probably have worked on them in the past. I'm just going to refresh those ideas for you. The next slide that you guys have, I want you to actually pause the video on the slide. Make sure you copy down all your vocab because those are really going to have all the properties that we're going to talk about in this lesson. So it's very, very, very important that you're copying down everything so you're ready for this lesson. For our first example, pause the video, copy down the problem, make sure you have everything. Our job is to solve this problem over here, but as we solve it, we need to name the property that's used in every step. One of the first things you want to do when approaching a problem like this is you want to solve it piece by piece. And if you do that, it's going to make the problem a lot easier so you can get the answer right without using a calculator. So I'm going to go ahead and rewrite the problem. 1/4 times 12 minus 8 plus 3 times 15 divided by 5 minus 2. Every time that we solve something new, we're going to write down what property based on those lists that you just copied that we did. So, looking at this, PEMDAS says that we solve inside parentheses, so we're going to have to do 12 minus 8 first. 12 minus 8 is the number 4, so I'm going to draw an arrow going down and saying I'm changing that to 4. I'm going to keep it inside parentheses because this 1/4 is there. So now looking at this, the only thing we did was we figured out that 12 minus 8 is 4. Well, that property that we're doing is actually called substitution. Substitution is when we solve something that we know and we replace it with what it is. So if we can take out 12 minus 8 and put 4 in its spot, that's substitution. So I'm going to write the word sub because that's the property that I just did in that question. Now, we're a little bit smaller and it's a little bit easier to work with. Now, there's nothing inside this parentheses that I can solve. I'm going to work my way to the right. In this parentheses, I have 15 divided by 5 minus 2. So now I'm going to do the division before I do subtraction because that's what order of operations tell me. 15 divided by 5, that's 3. So I'm going to replace that, which again would be substitution. So I'm going to write the word sub over here again. And we have 15 divided by 5, we get 3. We're going to bring everything else down after we solve that. Everything that we have not solved is going to come right down. Okay. Now, we look. Is there still anything inside parentheses that we can solve? This is solved. This isn't, so we can solve 3 minus 2. Well, 3 minus 2 is the number 1. So I'm going to go ahead and replace that with the number 1. Everything else is going to come down. Now, I know that this looks like a lot of work, but at the same time, we're working with small problems and easy problems that we probably have seen in the past. 3 minus 2, that was substitution. Now, we're supposed to start from the left side and work our way to the right when solving a problem, or at least this type of problem. So we have 1/4 times 4. Well, based on the vocab that you just copied down, this is called a multiplicative inverse. Any fraction times its reciprocal, which I can put the 4 over 1, which means it's the same fraction flipped. Any fraction times its reciprocal is the number 1. So I can take this entire thing right here and replace it with the number 1, and that's correct. Because 1 times 4, that's 4. 4 times 1, that's 4. So really, if I were to solve that, my answer would be 4 divided by 4. Any number divided by itself equals 1. And that's what the property is telling us for multiplicative inverse. Any number times its reciprocal, which means the same fraction flipped, will always equal 1. Here's a fraction times the same fraction flipped, we get the number 1. That's multiplicative inverse. So I bring out down my answer. I'm going to write over here that I did the multiplicative inverse. I'm going to use MI for multiplicative inverse. You don't have to write the whole thing out with me. I'd just be more at ease if you just write MI for abbreviations. Makes it easier and quicker to write. So we have multiplicative inverse property. If you didn't know it was multiplicative inverse and you don't want to write MI, I do encourage you to actually write the entire word. It is a fairly long word, but that's okay. You'll start learning that you did that property. I'm going to bring everything else down, and we're almost done. Now, there's no more multiplication, and we cannot do addition before we solve something else that's multiplication on the right side. So, 3 times 1, that's 3. And this is actually called a multiplicative identity. Any number times 1 is itself. So, 3 times 1, that's 3. That's multiplicative identity. I'm going to put inverse as INV, so I know it's an inverse, because now I said multiplicative identity, and that's an MI too. So here, I'm going to put M for multiplication, and identity, I'm going to put ID. That way I know it's multiplicative identity. And identity is when we multiply a number and we get ourselves. So 4 times 1, that's 4. That's an identity. 3 times 1, that's 3. That's an identity. So this entire problem up here that looks really complicated and hard is really the answer of 1 plus 3. Well, 1 plus 3 is 4. So our answer is 4. Now, there was one property that we just did. 1 plus 3 is 4, which means that we just substituted. We took what we saw, and we replaced it with what we know. So this is the substitution property. So you'd write the word sub for substitution. So here we have example 2. Make sure you copy down this question. In this question, we're still going to solve this problem, but I still want you to name the property as you solve the problem. So what we're going to do is we're going to solve it, and we're still going to follow the same rules that we did in the previous example. So looking at this problem, we look at it and we say, is there something inside the parentheses that we solve first? And if we do, we are going to replace that, and we're going to write down what property that we just did. So looking at this problem, the first step, I'm going to rewrite it. We have 1/3 times 10 minus 7 plus 4, 18 divided by 9 minus 1. So this problem looks really hard and complicated, but if we take it slow and we go through it, we'll get that answer real quick and easy. So first thing, we look at the parentheses. I have 10 minus 7. I know that answer. 10 minus 7 is 3. So I've solved inside that parentheses. Well, since I took what I know and I replaced it with what it is, that means I did the substitution property. So we write the word sub because that's the property we did. Bring everything else down. Now, there's nothing inside the first set of parentheses that we can solve anymore, so we're going to look at the second set of parentheses. Well, I know that 18 divided by 9, that's 2, so I'm going to replace it with a 2, which, since I replaced it, again, that's the substitution property. Substitution property is when we replace what we know with what it is. Bring everything else down. If you approach problems in this way, you're almost always guaranteed to get the right answer. Just work through it slow, and you'll get there. Nothing inside this parentheses I can solve. There is still something inside this parenthesis I can solve. 2 minus 1, that's 1. So I'm going to go ahead and bring that 1 down. Again, that's substitution because it's something that I can solve and replace. I'm going to bring everything else down. Now, we're going to start on the left side, work our way to the right. 1/3 times 3. This is actually another one of those instances of multiplicative inverse. An inverse is when you take a fraction times the same fraction flipped, and you'll always get the number 1. And the reason why, again, is 1 times 3, that's 3. 3 times 1, that's 3. And 3 divided by 3 equals 1. So the rules of multiplicative inverse is if you have a fraction times the same fraction flipped, you always get the number 1. So I'm going to go ahead and drop the 1 down, bring everything else down. So this looks pretty simple, but I'm still going to label what property I just did. I did the multiplicative inverse, INV for inverse. Now, the last thing we have to solve is we look over here to the right, and we have 4 times 1, that's 4. Now this is called a multiplicative identity because any number times 1 is itself. So we write M for multiplication and ID for identity. Drop everything else down. So this really hard and complicated problem really is 1 plus 4, which to us, that's pretty simple. That's just a number, 5. And that means that the last property that we just did was substitution. We took 1 plus 4 and we got 5, and that's our answer. Let's go ahead and do example 3. Quick change of pace. Now I'm at home. We're going to go ahead and finish out our examples and finish the lesson. You guys already copied down the vocab of commutative property and associative property, as well as all those other properties. This lesson right here is actually, this part of the lesson is actually going to be focused more on the commutative and the associative property. So here we have a real world example of something that could potentially happen. We're going to talk about horseback riding. So it says Zach made a list of different trail lengths to find the total miles he rode. Find the total miles that Zach rode. Now the idea is you're not allowed to use a calculator to solve this. So I want you to look at the total miles that he rode on the different trails. He has the East Trail, which is 4.25 miles, the West Trail at 6.50 miles, the North Trail at 9.0 miles, and the South Trail at 7.25 miles. Our job is to figure out if he rode all 4 of these trails, how many miles did he ride without using a calculator? So what we have is we have the commutative property. First, if we were finding the total, we'd add all these numbers up. So I'm going to go ahead and show you what these numbers look like all added up. So we have 4.25 plus 6.50 plus 9.00 plus 7.25. So if we're looking at these numbers, this looks like it could be added up probably pretty easy, but I could make this job easier by using the commutative property. What the commutative property says is that as long as all of my numbers are adding, I can actually move numbers around. Commutative property, move numbers. Associative property, move parentheses. So in this property, we're actually going to apply the commutative property, but then we're going to do the associative property to group things together. So association talks about groups, where commutative talks about things moving. So I'm going to look at this list. I'm going to say what could go together pretty easy. 425 could go together with 725. So I'm going to put those together. 425 plus 725. Go ahead and group those together. Here I got 650 plus $9. So I'm going to group those together. 650 plus $9. Now, by using the commutative property, which is what I just did, I moved the numbers around. The associative property is where I actually group numbers together. Now I can actually solve this. Well, I know that 4 plus 7 is 11. 25 cents plus 25 cents is 50 cents. So this would be 11.50, which means that that's 11.5 miles. Here, I have 6 plus 9, that's 15. 15 plus 50 is 15.50 miles. So what I'm really adding is I'm adding 1150 plus 1550. Well, 11 plus 15, that equals 26, but I have 50 and 50, so that's going to make one whole, which is going to bring me to 27 miles total. And notice I didn't use a calculator. What I did was the commutative property. I added numbers that were compatible together because they work well together and they're easy to do in my head. So 425 plus 725, 1150. 650 plus 9 is 1550. We add 1150 plus 1550, 11 plus 15, that's 26. 50 and 50 make an extra 1, 27, good to go. So when using the commutative property, you actually make problems easier if you move numbers around that are compatible. Let's go ahead and do another problem. In this example, what we're going to do is we're going to do a real-world transportation one. I didn't necessarily get this right because I know that we can't go from Cherry Street all the way to the airport on the train. But ideally, let's say we could. And so here it says Nick rode the city train from Cherry Street to the airport. How far did he go if he went through all the streets that are listed? So here I listed some of the streets that maybe Nick went through. He went through Cherry Street, and that's where he started with. So since he's starting at Cherry Street, he's starting at 0 miles. Washington Street, 0.6 miles. So he goes from Cherry to Washington, that's 0.6 miles. Washington to Water, that's an additional 1.2 miles. Water to Main, that's an additional 1.8 miles. And Jefferson to which is additional 1.9 miles. So let's say Nick went through all these different stops. What we would have to do is we'd have to figure out the total distance, not using a calculator. We're going to use the commutative property to figure out this answer, but let's start with figuring out how we'd find the total. Usually when we find the total, when adding things up, we put them all together. So we'd have 0.0 plus 0.6 plus 1.2 plus 1.8 plus 1.9. And I'm going to make my 8 a little nicer. Well, here in a second, apparently. Okay, it's better. Sure. So if we were adding these up, this might seem difficult for some to just do without a calculator. So what we are going to do is we're going to apply the commutative property. Since everything's adding, now remember commutative property only applies if everything's multiplying or adding. You can move things around. So since everything is adding, we're going to go ahead and put 0.6 with something that might work well with it. So 0.6, I'm going to put with 1.9. 0.6 plus 1.9. I'm going to group them together. Since I'm grouping, that's association, so that's the associative property. When we put things inside parentheses, we're associating them together, so we're grouping them together, associative property. I'm going to put 1.2 plus 1.8. And we know we're adding everything together, so let's see. Well, I'm not going to use 0.0 because 0 plus anything is still that number. So this, I'm going to kind of act like it's not there and just solve this part. 0.6 plus 1.9, that's 2.5, plus 1.2 plus 1.8, well, that's 2, plus an additional 1, that's 3.0. So really, this is 2.5 miles plus 3 miles, which is a total of 5.5 miles. So, this is the end of the lesson. What you need to remember is that commutative properties, when numbers move left and right, you can move them around as long as everything's multiplying or adding. Not dividing, not subtracting, only adding or multiplying. Then, the associative property is when we move the grouping symbols. We don't move the numbers, we can move the parentheses. Or we can actually put parentheses around something saying that we're going to group these things together. That's the associative property. So in this lesson, you learned all the different properties that we have, like multiplicative inverse, multiplicative identity, additive inverse, multiplicative property of 0, and all these different properties that end up solving problems. The main one that's always used is substitution. Make sure you have the list of your properties. We're going to practice a lot in the classroom. Be ready to go. If you haven't already, go ahead and like this video. Make sure you subscribe. Click that bell for notifications so you can see when I upload videos. And let's get ready for class tomorrow. Have a good day.